Yesterday we were looking at the erosion rates of Mount Mitchell and Mount Everest. And today we want to kind of take a little deeper look at what's going on there. So in the downloads is this form. So you can kind of follow along, fill it in. A lot of the stuff you can just copy what we're doing. And then on the bottom of the first page, the second page, and the fourth page, I'm going to let you kind of work on some questions there based on what we did. So we'll start off here. So first one, erosion rates versus uplift rates. So it says part 1, Mount Everest and Himalayas. The erosion rate for Mount Everest is 9.3 millimeters per year. The uplift rate, how much it's being lifted, how much it's growing each year, is 2 centimeters per year. Let's represent what this looks like in the space below so we can make sense of what this means for how the mountain is changing over time. So what we did here is we just made a drawing. So we'll just make a mountainy looking thing. And we want to put the rates on here. So erosion is happening on the outside. So we'll put erosion up here. And it is showing a 9.3 millimeter per year erosion rate. The uplift rate, we'll show it inside the mountain because the mountain's being pushed up. So we'll put down uplift here. That's 2 centimeters per year, but we want to keep it the same units, so we want millimeters. So that's going to turn out to be 20 millimeters per year for uplift. Okay, so I know it says 2 up here, but we're trying to keep these in the same units. So 20 millimeters is 2 centimeters. And that's pretty much all we can do right now. We're going to come back and fill in some other stuff, but that's what we have for this one. We go down a little bit. There's a sentence here. It says, what's the relationship between uplift rate, erosion rate, and elevation change of a mountain? Use the sentence below to capture what is happening at Mount Everest. So it has when the uplift rate at Mount Everest is blank, and we have 2 options here, greater than or less than. The erosion rate, the height of the land at Mount Everest, will blank, and it's either increase or decrease. So if we look at the top here again, the uplift rate is greater. Okay. So the uplift rate at Mount Everest is greater than the erosion rate. And so if the uplift is higher, that means the mountain will increase. And all I do is I look at these 2 numbers. Oop, I forgot the down arrow here. So erosion is making it go down, shrinking it. Uplift is making it go up. So I look at the 2 numbers. 20 is bigger than 9. So whatever arrow goes with the higher number is what wins. So it's going to be going up. 20 is larger than 9. Question on the bottom says, if you were to see Mount Everest in 1,000 years from now, do you predict there would be any noticeable changes? And I'm going to let you kind of think about what it means by noticeable. So you got to kind of think about that first. And then also, do you think it's going to be taller or shorter based on what we saw in this diagram? And then finally, why are you giving those answers that you're giving? So when you're ready to do that, you can do that. I'm going to go on to the second page. This one is for Mount Mitchell. So Mount Mitchell, the diagram looks the same. So we have just different information. We're going to do the same thing pretty much. So we have a mountain, and the erosion rate is 5 millimeters going down, 5 millimeters per 1,000 years. Okay. The uplift rate, which is right here, is 1 millimeter per 1,000 years. And that's all the information we can put in there for now. We go down to the same thing here. We have the same sentence. So again, we look at the 2 rates, both the same units, millimeters each. 5 is bigger than 1. So the erosion, forgot to put this here. The erosion rate is greater than the uplift. Okay, so when the uplift rate at Mount Mitchell is greater than the erosion rate. The height of the land at Mount Mitchell it's going to shrink, so it's going to decrease. Okay, so again, we just looked at those two numbers. We found the bigger one, 5. Whatever that arrow is doing there is what wins. So it's going down more than it's going up, so it'll end up going down. Same question again, except it's about Mount Mitchell. If you were to see Mount Mitchell in 1,000 years from now, do you predict there would be any noticeable changes? Do you think it would be taller or shorter? And again, why do you say that? So you can take a few minutes to do that. We'll continue on to page, we're actually going to go back to page 1. We want to add some more stuff to that. So going back to page 1, we wanted to add some more information to this chart. We wanted to add some causes. We know why some of these things are happening. So we talked about it in class, and we said the uplift is happening because plates are moving, and plates are moving because we have magma pushing up. So what we did here is we just drew a layer of bedrock, so BR for bedrock again, and then magma down here. And then we pointed an arrow from magma towards the uplift, saying that kind of causes that. So the magma causes the uplift, and we were trying to figure out what causes erosion, and we said it has to do with water and wind and ice forming and cracking the rocks. So these cause the erosion. But we wanted to go one step back. What causes water and wind and freezing? Those are all about weather. And the thing that causes the weather is the sun. So the sun causes the weather here. So we get the water cycle from heating of the air. Hotter rises, moisture can't be held in the air anymore, so it starts raining. Air is heated up differently, so we get wind. If it's not warm enough from the sun, there's freezing. That leads to our erosion. This picture here we want to put on the other one. So I'm just going to copy that whole diagram onto page 2. So I'm going to put down our bedrock down here. We'll put our magma here. We've got wind, water, and freezing here. Those 3 all cause erosion. What causes those 3 is the weather, which is caused by the sun. So basically the same diagram we just did on page 1. That fills in page 1 through 2. We go to page 3. We're going to do a little bit of math here. So you can just copy what I've got. There's one more question that you have to do, which is on page 4, but we have to get through a couple things first. So on this one, it says we're going to assume that for Mount Everest, that the erosion rate stays at 9.3 and the uplift rate stays at 20 millimeters per year. And how much will the elevation change in 2 different time periods, in 1,000 years and in 1,000,000 years? So we know that it's going down 9.3 millimeters per year. We know that it's going up 20 millimeters per year. Overall, it's going up 10.7. If we take 20 minus 9.3, we got to find the difference between these. So it's actually 10.7. 20 is larger, so this is ending up going up. So it goes up 10.7 millimeters each year times 1,000 years. So 10 times 1,000 would be 10,000. So this is going to be 10,700 millimeters. And we figured this out, that 10,700 millimeters comes out to be 10.7 meters, which is about 30 feet. Okay. Then we want to go to the next part. How about in 1,000,000 years? Well, we could go back, we could multiply this by 1,000,000 and all that stuff. We could also use the fact that a million is really just 1,000 thousands. We've already figured out 1,000 years, so we just going to multiply this answer by 1,000, and we'll get a million. So we're going to take 10.7 meters times 1,000. That will give us 10,700 meters. And that's going to be about 10 kilometers, which would be about 6 miles. So there's a huge difference there in a million years. Okay, so that's for that page. We're going to do the same thing for Mount Mitchell, except we have different numbers. But here's that. So again, we assume that it's going to stay at 5 millimeters erosion, plus with a 1 millimeter per 1,000 year uplift. So it's going down 5 millimeters per 1,000 years. It's going up 1 millimeter per 1,000 years. What that means is it's going to be a difference of 4 going down. So it's going to go down 4 millimeters every 1,000 years. And they wanted to know how much it was going to go down in 1,000 years, so we have our answer, 4 millimeters. The second one, we wanted to do what about a million years? Well, like we did in the last one, a million years is really 1,000 years. So we take the 4 millimeters times 1,000. That'll give us 4,000 millimeters. 4,000 millimeters is just 4 meters, which is roughly about 12 feet. So Mount Mitchell will go down about 12 feet in a million years. Okay. So that's, you can just copy all that stuff down. We just calculate it out for you. Your last question is at the bottom on page 4. It says, using your predictions above, which mountain do you predict will change the most over the next 10,000 years, and why? And you can use all the calculations we just did on all the pages before that, so you can use all the information to help you out. Just want to point out a couple things. One, they are asking about 10,000 years, not a million or 1,000. They're not asking which one's going to shrink or grow. They're just asking which one's going to change the most. Okay, so I just want to point that out. They're not looking for some of the answers we had here. So you got to think about this. This is 1,000 years. That's a million years. They want to know about 10,000 years. They don't want increase or decrease. They just want to know which one's going to change the most. So fill that in, and then you can submit that to the assignment for today